This is part of a project to 3D print an entire model railroad other than the electronics. Today, we're going to create rolling stock in the form of boxcars, with a focus on functional trucks and wheels and couplers. We start with National Model Railroad Association specs. The NMRA has a lot of information, but not as much as I was hoping for. They do have a lot of information on the wheel sets, so that's where we will start. We start drawing the wheels in FreeCAD with a general outline of one half of the wheel set. Sometimes adding dimensions in FreeCAD can warp the sketch, but fortunately, the unconstrained lines can simply be pulled around with the mouse to correct the shape. I also leave all the radii off the sketch for simplicity. The NMRA has a strange way of dimensioning the gauge, from the back face of one wheel to the rail-facing flange of the other. I would dimension it from one rail-facing flange to the other, as that's what actually interfaces with the rails and controls the gauge. When the sketch is complete and dimensioned, I revolve it, then mirror it on the plane of the center of the axle. Now the chamfers are added, including the all-important one, at least if you don't want to break them during the installation, between the axle and back of the wheel. Now we move on to the rest of the car. The NMRA specs have scant little info on trucks, couplers, or the rest of the car, so I pulled apart some ones I already had and measured the parts. So it's got couplers mounted on the trucks. First thing we'll do is pop the body off. Okay, so some things to make note of. The ridge here locates it, and a cutaway on the end. Now let's look at this. The body is die cast for weight. The steps are plastic molded pop-off. Trucks are held in with pins. Push pins, not screws. Wheels out. Plastic wheels. The trucks are obviously plastic. Okay, then there's the coupler. Ooh, the coupler opens. I thought these were simply one piece. Let's take it out. The cover looks like it slides back, up. Come on, focus. Too close for you to focus. Ooh, it's coming apart. So it is two pieces with a spring. Which must center it. Yeah. So there's an upper piece with the knuckle, lower piece with the other part of the knuckle. Slide together, make a coupler. It can open. So those are the parts we need to make. And the truck. So this is the primary thing we need. And then our floor and the body. Now that everything is disassembled and I know how it works, I take the measurements I need to create the 3D models. I also took some photos with a ruler in the shot so I can import the pictures into Blender and use it to make a scale part. I'll go over modeling the trucks and couplers as they're the most interesting and complicated parts. After importing and scaling the reference pictures, I start with a plane, loop cut it, delete half, and add a mirror modifier, so I only have to draw half and I know it's symmetrical. Then I add points with subdivision and move them around till they match the profile. I inset the faces and delete the troublesome parts. Then add some vertices and faces until we get the shape of the truck frame. Let me know if you like going through the model design process or not. My aim is to show the steps I went through with enough detail that you can duplicate it yourself with the help of a basic Blender tutorial, but not bog down the video with an in-depth step-by-step tutorial. Next, it gets tweaked to match the shape. Then extruded to give it a thickness. Next, the bolster face is inset, then extruded to give it some depth, and again to make it protrude from the frame. The bearing box gets the same, then its face is tilted. Again it gets an inset, then extrusion to give it some relief. A circle is added and gets a screw modifier plus some tweaking to form a spring. It's duplicated and moved into position. The area of the frame right behind them is set back, then the springs are joined to the truck body. The truck half gets a mirror modifier and is moved the right distance apart, then exported. In FreeCAD, the frame is imported and the center section is constructed. It's a fairly simple matter to add the bolster and coupler mounting plate. The coupler halves are much the same as the truck, except this time I start with a single vertex, extrude it around the coupler shape, then create faces and extrude it to the right thickness. Next, I create a string of vertices to extrude the knuckle itself from the shank, and extrude it, then repeat that on the bottom of the shank. A circle is added to extrude a pin that restricts the swing of the coupler. Another circle is added for the pin that locks the two coupler halves together. On the commercial cars, this is the metal air hose that allows magnetic uncoupling. I'm just using a pin because we aren't going to have magnetic uncoupling to keep with the 3D printed challenge. The last part is a spring. This is a conventional metal spring in the commercial car, but I'm going to make it more of a folded leaf spring and integral to the lower coupler half. This gives it something more substantial to be attached to during printing and eliminates the single most frustrating part of putting the coupler together, getting that little spring to stay in there while you put everything in. And I'll admit up front, there is zero engineering in the spring design, just an educated guess at how thin a section I can print because the reference springs force seems to be more than none, but not by a lot. In addition to the wheels, trucks, and couplers, I'm making the truck pins, car floors, coupler covers, and car bodies. I'm leaving a lot of the detail out on the body because this is a proof of concept and I know I'll be handling it a lot. I discovered an issue with exporting STLs from FreeCAD. With the default setting, the model is highly faceted, which is not going to work well for a wheel. To fix this, we go to Preferences, Part Design, Shape View, and change the maximum deviation percentage. I changed it to 0.01% from the default 0.5%. This makes the exported STL much better and usable. If you're enjoying the video and getting some value from it, please hit that like button so more people get the chance to enjoy it too. Now we hit some trouble. The first issue is the fit of the wheels to both the trucks and the track. They fall out of the trucks far too easily, and are very tight on the track. This is fixed by lengthening the axle to match the commercial cars and reducing the wheel spacing to account for the radius between the flange and the wheel. The second issue is the fit of the coupler cover on the truck. This is due to only measuring the parts and not calculating the dimensions. The slot that fits over the tab on the coupler is too narrow. The third issue is the fit of the coupler pin, again from measuring and not calculating. The fourth issue is the fit of the body to the floor. In my excitement to make the trial part and see how things work, I forgot the step in the body that allows the floor to fit inside at the proper depth. This shows why it's always a good idea to print test parts before making all the parts for a project. Time to put everything together. I start with the hot water method to assist in removing the parts from the supports. The two halves of the coupler get placed on top of each other and locked together. Then they get located on the truck. While holding them on, the coupler cover gets carefully slid over and locked into place. I have to say it's much easier to do this without a separate spring that keeps popping off and rolling under something on the floor. Next, the wheels go in. The inner wheel set is pretty easy, but the front one requires maneuvering the wheels between the frame and coupler and makes it all too easy to break the frame. Now the trucks mount to the floor using the mounting pins. Using the hobby knife as a press is not the recommended procedure, but I managed to do it without losing a finger. The body slides over the top and the car is assembled. All these steps were repeated off camera to produce 2 cars. This is chassis number 1. This one does not roll so well. Now let's try chassis number 2. And I did oil these a little bit with some machine oil. At first I tried graphite. I wasn't sure if oil would eat the plastic. Oh, that rolls a lot better. So I'll have to try to figure out what's different between these two. And they're weighted to NMRA specs. So let's come in here and couple them. Coupled. Excellent. Okay, let's see if we can uncouple. There's not a whole lot of room between them, is there? Oop. I think that's going to be difficult no matter what. Just because there's no room to get the pick in. Okay, so we know they couple. Now let's test against a commercial car. I think commercial cars roll quite a bit better. The second one is close. I like this one's really free. So free, it drove off the end of the world. Okay. So those couple like you'd expect. And there's more clearance between them. Oh, put my fat hand in there. Let's do it left-handed. Can get them apart. Let's put one in the middle. Yeah, okay. Couples up. Couples up. So we can uncouple them. But there we go. So it works. There are improvements to be made. Figuring out the best resin for the wheels and trucks, refining the coupler spring fit to the locating pin, getting a little more room between the cars for uncoupling, and adding detail to the bodies. There's more to come. We'll be creating a base, track, scenery, buildings, and a locomotive. So subscribe if you want to follow along. Thanks for watching.